Good day, guys, and welcome to this class. And today we'll be solving questions based on modern physics. And this question covers areas such as quantum physics, photoelectric effect, atomic structure, nuclear physics, and radioactivity. So let's dive right into the questions. Good day, guys, welcome to this class. And today we'll be solving questions based on modern physics. And this question cut across many subtopics such as quantum physics, photoelectric effect, atomic structure, nuclear physics, and radioactivity. Meanwhile, we've done a full video of this topic in our channel. Don't forget to go back to the channel to check it out. Let's dive right into these questions. Question number 1. It says, the energy of a photon is directly proportional to its dash. The energy of a photon is directly proportional to its dash. Now, I explained when I was explaining the photoelectric effect, and I explained what a photon is, and I told you that the energy of a photon is directly proportional to its frequency. So the frequency of a photon is directly proportional to the energy of a photon. So the correct answer to this question is option B, which is what? Frequency. So that takes us to question number 2, which says, which of the following best explains the term quantization of energy? Option A says energy is continuous in all physical process. Option B says energy exists in discrete packets called quanta. Option C says energy cannot be transferred. Option D says energy is always conserved. Now, in a video that I did on modern physics, I said that what? Energy exists in discrete packets called quanta. So the correct answer to this question is option B. So that is also question number 3, which says, if the Planck's constant H is equal to, so my H is equal to 6.63 times 10 raised to power minus 34 joule seconds, the energy of a photon, so we are looking for the energy of a photon of frequency 6.0 times 10 raised to power 14 hertz. So we know that the energy of a photon is equal to Planck's constant times the frequency. This means that my energy is equal to 6.63 times 10 raised to power minus 34 times 6 times 10 raised to power 14. This is the same as I have 6.63 times 6 times 10 raised to power minus 34 plus 14. So this will give me 6.63 times 6. So that will give me 39.78 times 10 raised to power minus 20, which is the same as saying that I have 3.98 times 10 raised to power minus 19 joules. So the correct answer to this question is 3.98 times 10 raised to power minus 19 joules, which is option A. Moving on to question number 4. It says, the stopping potential in a photoelectric effect experiment depends on dash. The stopping potential in a photoelectric effect experiment depends on dash. Option A says the intensity of the incident light. Option B says the frequency of the incident light. Option C says the distance of the light source. Option D says the surface area of the photocathode. Now, when I was explaining the photoelectric effect in the topic that we did on this topic, I said that what the intensity of the light only determines the number of electrons, but it does not determine whether the electrons will be emitted. That the factor that determines the emission of electrons is the incident frequency, the frequency of the incident light. So the correct answer to this question is the frequency of the incident light, which is what? Option B. So that is also question number 5, which says, in the photoelectric effects, electrons are emitted from a metal surface when dash. Electrons are emitted from a metal surface when dash. A, when the light intensity is high enough. B, when the photons of sufficient frequency strike the surface. C, when the temperature of the surface increases. and D, when the cathode is positively charged. The correct answer is when the photons of sufficient frequency strike the surface, which is what? Option B. Remember in that what topic I said that what the frequency of the photons that are striking the metal must be higher than the threshold frequency of the metal itself. So the correct answer is option B. So that is also question number 6. We say the threshold frequency for a certain metal is, so we have this threshold frequency F naught to be 5 times 10 raised to power 14 Hz. They said if light of frequency, so we have the frequency of light to be 7 times 10 raised to power 14 Hz falls on it, the photoelectron energy is determined by dash. So what they're asking us, now this is my threshold frequency of that particular metal. And this is the what? Frequency of the light that is incidented on the metal. Then they're asking us, what determines the photoelectron energy? What is going to determine the photoelectron energy? What will allow electrons to be emitted from this metal? That's what they're asking us. So option A says the wavelength. Option B says the difference between photons and threshold energies. Option C says the intensity of light. And option D says the charge of the electron. Remember I said that for electrons to be emitted from a metal, it means that the frequency of light incidented on it must be what? Greater than the what? Threshold frequency. So the correct answer to this question is difference between the photons and the what? Threshold energies, which is what? Option B. So that is also question number 7, which says, according to Boyle's model, electron in an atom move dash. Now, according to Niels Boyes, they are asking us, what did Niels Boyes' model of the atom say? So, option A says circular orbits, that they move in circular orbit with continuous energy level. Option B says they move in elliptical orbit with random energies. Option C says they move with fixed orbit with quantized energy levels. And option D says they move straight lines with no energy. Now, according to Niels Boyes, it said that they move in fixed orbit with what? Quantized energy level. So the correct answer to this question is what? Option C. So that takes us to question number 8. Which says the hydrogen atom spectrum has discrete lines because of that. The hydrogen atom spectrum has discrete lines because that. Option A says because the electrons move freely in atom. Option B says because transition occur between quantized energy level. Option C says because the nucleus vibrates continuously. And option D says because the protons capture electrons randomly. So now the hydrogen atom spectrum has discrete lines, and the reason is because there is transition that occurs between the quantized energy level. So there's what? A transition that what exists between the what? Quantized energy levels. So that is why there's what? Discrete lines in the what? Hydrogen atom spectrum. So the correct answer to this question is what? Option B. Moving on to question number 9. It says, which of the following series of spectral lines lies in the visible region of hydrogen? Now, in the visible region of hydrogen, what you have there is the Balmer series. So it is not the Lyman series, it is not the Paschen series, and it is not the what? Bracket series. So in the visible region, in the Lyman series, what you have there is the ultraviolet series. So it is the ultraviolet region that you have what? In the Lyman's what? Series. But in the Balmer series, what you have there is the visible light. So in the visible light is what is present in the what? Balmer series, but not in the what? Paschen series, the bracket series, or in the Lyman series. So the correct answer to this question is option B, which is what? Balmer series. So that is also question number 10. We say the mass defect of a nucleus is due to dash. Now remember that we talked about what? Mass defect when we talking about what? About Einstein's equation, where we said that what? E is equals to what? Change in mc squared. Where we said that what? your change in M here is called what? Mass defect. So they're asking us, what is causing this mass defect? The mass defect of a nucleus is due to what? What causes the mass defect in what? In a nucleus. And the mass defect in a nucleus is caused by what? The binding energy. It is the binding energy that causes what? A mass defect in what? In a nucleus. So the correct answer to this question is option B, which is what? Binding energy. So that is also question number 11, which says, which particle has no charge and almost negligible mass compared to a proton? It has no mass and it has what? Negligible mass compared to a proton. Now the first one is the neutron. Now the neutron has a mass. It has no charge, quite all right. So has no charge and almost negligible mass compared to a proton. It has no what? Charge, but it does not have negligible mass. It has a mass that is almost equal to the mass of what? A proton. So that means that what? The neutron is not the correct answer. Option B says the word electron. Now the electron has a charge, so automatically it cannot be what? The electron. Then the next one is the photon. Now the photon is electromagnetic in nature, so it cannot even be what? The photon. So the correct answer to this question is the neutrino. Now the neutrino has no charge and it has what? A mass that is very, very small when compared to the mass of the proton. So the mass is negligible when compared to the mass of what? A proton. So the correct answer to this question is neutrino, which is what? Option D. So that is also question number 12, which says, nuclear fission involves dash. Now, when I was explaining the nuclear reaction, I said that we have got two types of what? Reaction in that what? Topic, when I was explaining the topic. And we have what? Nuclear fission and nuclear fusion. So they're asking us, what does nuclear fission involve? So if you have not watched that video, go back to that video and check out the explanation I gave on nuclear fusion and nuclear fission. So they're asking us here, what does nuclear fission involve? So option A says the splitting of heavy nucleus into lighter ones. Option B says joining of two light nuclei into a heavier one. Option C says emission of beta particles only. Option D says emission of alpha particles only. Now when we're talking about nuclear fission is the splitting of a heavy nucleus into lighter ones. So when a heavy nucleus splits into lighter ones, we call it what? Nuclear fission. So the correct answer to this question is option A. So that is also question number 13. We said the half-life of a radioactive isotope is the time taken for dash. So when I was explaining radioactivity, one of the concepts that we talked about was half-life, where I said that the half-life of a radioactive element or radioactive isotope, as in this case, is the time it takes that particular isotope to divide up to half of its mass. So the correct answer to this question, let's look at the options. Option A says is the time taken for all the nuclei to decay. Option B says is the time taken for half the nuclei to decay. Option C says is the time taken for activity to increase by half. Option D says is the time taken for energy to double. So the correct answer is that it is the time taken for half the nuclei to decay. So the correct answer is option B. So that takes us to question number 14, which says a radioactive element has a half-life of 3 hours. So we have the half-life, T half, as 3 hours. If its initial mass is 80 grams, our initial mass is 80 grams. They said the mass remaining after 9 hours is dash. Our N is unknown. So we know our number of half-life here is, so they said after 9 hours, so that's what? So my T was given as 9 hours, and my number of half-life here is T over T half, which is same as saying 9 over 3 hours, which will give me 3 half-lives. 3 half-lives. So I have 3 half-lives here. So my the quantity that will be left, or the mass that will be remaining, the mass that will be remaining here can be calculated using this formula. So if I want to calculate the mass remaining, I'll simply tell them that the mass remaining N is equals to N naught, open the bracket, 1 over 2 raised to power N. So this is the same as saying that my mass remaining is equals to 80 times 1 over 2 raised to power 3. So this is the same as saying I have 80 times 1 over 8. So it means I'll be having 8 here 1, 8 here 10. So at the end of the day, I'll be having 10 grams. So it means that after 9 hours of what? This particular isotope or element breaking itself down, after 9 hours, I'll be having only 10 grams of this particular substance remaining, which is what? Option C. So that is the question number 15, which says, gamma radiation differ from alpha and beta radiation because it dash. So, what is the difference between alpha, beta, and gamma radiation? What separates gamma radiation from both alpha and beta radiation? Option A says, because it has mass and charge. Does gamma radiation have mass and charge? Option B says, because it is a wave with no mass or charge. Option C says, because it is deflected strongly in electric field. Option D says, it consists of helium nuclei. Please note that it does not consist of helium nuclei. That is what? For alpha radiation. And it is not deflected in an electric field. That is for what? For alpha and beta. So it is not what? Deflected. So option A says it has mass and charge. It does not have mass and charge. So the correct answer is that it is because it is a wave with no mass or charge, which is what? Option B. So we've come to the end of this class. Thank you for sticking with us. Don't forget to go to our channel for more videos just like this.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao,